Hello everyone. This question belongs to the simply Ohm's law and the connection of the resistors, the parallel connection of the resistors. So question is, three resistors of resistance R1, R2 and R3 are connected as shown in figure 6.1. The currents in the resistors are I1, I2 and I3. The total current in the combination of resistors is I, and the potential difference across the combination is V. So you see here that the potential difference across combination is constant, which is V, right? And this I is enters here and then distributed. This I1 is going here, I2 comes here, some I dash comes here, and which is distributed in I2 and then goes to I3. Okay, there are three currents, I1, I2, I3, but only one voltage. So we are very familiar with Ohm's law. So Ohm's law, which is a very famous law for this electricity, and which just simply states that V equal to IR. Okay. So now the thing is, what is written here, the potential difference across the combination is V. That means if you will measure, simply if you took a voltmeter and you measure the voltage here, it will give you voltage V. If you will measure across these two terminals, it will give you V. If you measure across these two terminals, it will again give V. That means voltage measured is constant. So that means if you will measure V, because IR, so it will be I1 R1. Okay. V here it will be I2 R2, and V here will be I3 R3, right? And this total current is I, so that means I is also equal to I1 plus I2 plus I3, because if this I current is distributed among these three branches. Okay, because this is the input current, this is the output current, you can say. So now if we just put the simply values of I1, I2, I3 from here, so we will have V upon R1 plus V upon R2 plus V upon R3. There is no harm in that. You can write in this way. Now, if we consider that there is equivalent resistance R such that, if just example, if there was a if we think that there is a source here, for example, this is a battery source. So this is the positive terminal, the negative terminal, this way. And if we just replace all these resistances and we just connect only one resistance R, this way, R, and we connect battery in the same way. This way. So this is the R, and the voltage of the battery is same V. So it will be current I. So that means V equal to IR, and I will be equal to V upon R. So that means it will be V upon R. So if you take V common in the right hand side, it will be V by R is equal to V common 1 by R1 plus 1 by R2 plus 1 by R3. Just if we cross V and V, cancel out V and V, so it will be like 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3, right? Which was this the formula. That means in the parallel combination, 1 by R will be equal to summation I1 equal to N if there are N resistances, and this will be equal to 1 upon Ri, where R varies from 1 to N. If there are combination of N such resistors in the parallel, okay, so that means in the parallel combination, always distribution of current happens and voltage remains constant. And this is the formula for calculating the equivalent resistance for a parallel combination of the resistors. So this one is the formula.